Okay, we just have explained question 1 and question 2. Then we go to question 3. Okay, question 3. Okay, the 10 cm cube of hydrocarbon A were mixed with 40 cm cube of oxygen in excess, highlight some keywords, in excess, okay, and exploded. After cooling the apparatus, now cooling is also very important because if you think about when a hydrocarbon is burned, what kind of products will be formed? Carbon dioxide and water, right? So since the temperature is very high at the very first place, the water is actually coming out as steam. But after cooling the apparatus, the steam will be condensed to water droplets, okay? So when you consider the calculation of the gases, you don't have to include the steam because it's already condensed to water, okay? 好，now let's go through this together. You burn hydrocarbon, you don't know what the hydrocarbon is, so we can simply let it be X and Y. And now you have to determine the formula of A, showing all the working steps at the end of this question. So basically you are solving X and Y, right? So now we try to work out a balanced equation in terms of X and Y. For this equation, actually I asked you to remember it even though you were in IGCSE. I don't know if you still remember, but you can also balance it, okay? X carbon, so you need X. Then you have X carbon on the right-hand side. Y hydrogen on the left-hand side. So you need Y over 2, okay? Now we will balance the compound first and leave the element at the end to balance because this is very simple because the compounds, they're associated with more than one element. If you change one number, you change the other one. But if you leave the element at the end, you just have to deal with that element, okay? So, and then you calculate the total amount of oxygen on the right-hand side. Here is 2x, right? 2x. And here is y over 2, right? So you need x plus y over 4. So that when 2 times this x, you have 2x. When 2 times this y over 4, you have y over 2. Then you can balance the number of oxygen on both sides as well. Okay, now let's take a look. Right now, you have this hydrocarbon A, right? Then you burn it in oxygen in excess, okay? So you have 10 cm cube, 40 cm cube. Now you need to know the flow of what you're doing. Then it come out with carbon dioxide and water, but since it's cooled down, the water comes out as water, liquid water, okay? So, and also the oxygen, the remaining, because the question is telling you that this is in excess. So everything is gone after the first step. You will have carbon dioxide and remaining oxygen. The water can be ignored because it's condensed back to liquid water already. So the third, and then here will be 30 cm cube, okay? This one and this one, 30 cm cube, okay? And then was shaken with excess aqueous potassium hydroxide. So what's the use of potassium hydroxide? Potassium hydroxide is alkaline, of course, it's going to help you to absorb the acidic gas, which is carbon dioxide. So it will help you to remove CO2, and then you only have remaining oxygen left. Then the volume reduces to 20 cm cube. Now that is the flow of the question, okay? That is the flow of the question. Originally, you have 10 cm cube of CHY and 40 cm cube of excess oxygen. After combustion and cooling, you will have carbon dioxide produced together with the remaining oxygen, the unreacted oxygen. And it makes up to the total volume 30 cm cube. And after shaking this gas mixture with potassium hydroxide solution, the volume of the gas was reduced to 20 cm cube because the carbon dioxide is absorbed as potassium hydroxide is alkali, okay? 好, name the gas in the 20s that remained at the end. B, well, easy, all right? So remaining name, it will be oxygen, all right? C, name the gas produced by the combustion that will react with aqueous. Carbon dioxide. Remember, name, name. Name, do not write CO2, you will lose marks. Name. Calculate volume of oxygen used up. That's easy. Now, think about, originally, you have 40 cm cube. After so many steps, the remaining oxygen is 20 cm cube. So the volume of oxygen that's really used in the reaction will be the original minus the remaining, which is 40 minus 20. So it will be 20. Okay. Okay, hence determine the volume. Oh, okay. Now then we go back to this. Now now we look at these. No, sorry. Okay, here we have one more information. Now 30 cm cube after passing KOH, you have 20 cm cube oxygen left. So which means the volume of carbon dioxide is what? Is 30 minus 20. Do you agree? Okay. Originally 30 cm cube, including carbon dioxide and remaining oxygen. After passing through potassium hydroxide, which can help you to remove the carbon dioxide, 20 cm cube of oxygen remaining, which means the volume of carbon dioxide produced is actually 30 minus 20, 10, okay? Oh, now I want you to look at this one, okay, and this one, okay? The mole ratio is 1/x, okay? What I'm doing is mole of CHY over mole of carbon dioxide will be equal to the volume of CXHY over the volume of carbon dioxide. This is Avogadro law of gas, right? When every gas is put in the same condition, the volume is actually directly proportional to the number of mole, right? So from the equation, CXHY is 1. This is x, okay? So it will be 1/x. And volume of CXHY is given 10 cm cube. Volume of carbon dioxide, as I told you, is also 10. So x will be equal to 1. Easy, right? So your next task will be solving y. Then I will look at this one and oxygen. Okay, this time, now can you see the mole ratio? X plus y over 4 and then 1. So this time I will try to do it like that. Mole of oxygen over mole of CXHY, okay, equals to the volume of oxygen over volume of CXHY, okay? Mole of oxygen, when you look at the equation here, okay, here, mole of oxygen is x plus y over 4, and mole of CXHY is 1. So it will be x plus y over 4, 1. And volume of oxygen reactor is 20. Okay, volume of oxygen reactor is 20. Volume of CXHY is 10. So it will be 1 x plus y over 4. From the above calculation, x is equal to 1, right? So we can substitute 1 here. Sorry, this is 2. This is 2. Sorry, 20 divided by 10 is 2. Sorry. Okay, then what we'll be doing is 2 minus 1. Y is 4. Okay, understand? So basically, we try the method for us to tackle this question is you have to know the flow, and then second one is you have to consider the mole ratio together with the volume ratio of each step of each gas. Then you can solve X and Y. So right now, at the end, X is equal to 1, Y is equal to 4. So A will be CH4. Okay, it's a mathing. Okay. So let's see if you understand. If you don't understand, you can rewatch the video. If you still don't understand, you can let me know and then I will explain it to you. Okay.